Okay, hello. It is Saturday. I am going to make a Tweetjam, possibly a toot cart if I run out of space. I figure if you're watching my video, you maybe already know what a Tweetjam is, but if you don't, it is a 280 byte Pico 8 demo. A toot cart is the same, but 500 bytes, because that's the Mastodon size limit. I have a general idea for what I want to do today, but not a really specific plan. To show it, I'm going to run over to Desmos. So, this is Smooth Step. Everybody likes Smooth Step. It is a lovely little function. And people who use Smooth Step know that there's a golden rule, which is that you always stay inside of this range from 0 to 1, because this is where it has the nice easing function properties, where it starts and ends at 0 and 1, and it is totally horizontal at the beginning and at the end. But today, we're going to break the rule, and we're going to go a little bit outside of that range, because if you look at this area that goes a little bit into the negatives, this curve, if you looked at it sideways, it kind of resembles the profile of like a goblet, and making a 3D goblet with the lathe tool is like everybody's first 3D modeling exercise, I assume. So that seems like a pretty simple shape. And I'm just going to try to make one of those. Also, a simple tweet cart for me pretty much means it's going to be a spinning thingy, so that seems like a good spinning thingy to do. And then we'll figure out some kind of weird pattern and colors to put on the sides. I don't really know what that's going to be yet. But the general plan of doing a goblet seems like a nice one to do, because I haven't done a Tweetjam in quite a while, so I'm a little out of practice. So to start, we do our go-to loop. This is a little bit shorter than a while true. We have a CLS at the beginning, clear the screen. We have a flip at the end to wait for the next frame. If we run out of space, we can replace that with a slightly shorter magic P8 ski code, but I don't remember what that is offhand. I have to Google it every time I do it. So I start with this one instead because it is easier and still pretty short. Let's see. So spinning thingy for me pretty much always means we're going to loop over a bunch of Y positions. We're going to go from 0 to 1. We're going to step by some very small amount. Actually, we're going to go from 0 to some number so we can count by integers. And that'll make it easier for us to apply the other really super common trick I do for all of these, which is to use the golden angle, because we want to cover our surface radially very efficiently, and we don't necessarily know how many points we have beforehand, and we just want it to be a good coverage. That's kind of the same problem that a plant has when it's placing its sunflower seeds around a central point. And for the same reason, golden angle is very, very helpful here. It gives us a very nice coverage. So we're going to pick an angle, and that's going to be our integer y. And I'm going to make this I, actually, because we'll get an actual y position in a second. And we're going to multiply that by 0.618, which is one of the versions of phi, which is how we get our golden angle. Pico 8, the angles are revolutions instead of radians or degrees, so we just have 0.618 directly. If you were working in radians, you'd multiply that by 2 pi. But we don't have to, because Pico 8 is very nice, very nice setup. Revolutions are a good way to go. So let's see, we have that. Now we can figure out an x and a z position, and those are just going to be based on cosine and sine to go from an angle to a direction. And then our y is going to be I divided by our total count. I'm going to go to 99 instead of 100 because that takes one fewer character. It is pretty much the same. So now at that point, we have a 3D position, x, y, z. I'm going to scoot this there. I'm always wondering if it makes more sense to put these together or to put the x and z together because they're kind of the same deal, or to do x, y, z in order. It doesn't it doesn't matter, but it's a it's a style thing that gives me some anxiety. Let's see. We have an x, y, z position. We want to map that to a screen position. So we're going to do a p set to draw something to the screen. We're going to do 64 plus x times something. I don't know, let's say 30. And then our y is going to be I mean, whatever. We'll start in the middle, too. We'll move this in a second. 64, we're going to subtract our Y position times some large amount. I don't know. 50. And we're also going to add our Z position so that we have kind of a downward tilted looking view. Something much smaller. I don't know, like 10, 15. And then we'll pick a color. This doesn't really matter yet. We're just going to do 6 for gray because we're going to replace it anyway. So let's run that. That gives us a very bad looking, hard to understand cylinder. To see what the cylinder actually is, let's get a T value. T for time is already used. I'm just going to call it W. I don't know why. I don't know what W stands for, but it stands for time. WIME, if you will. Okay, now that's spinning really fast. Let's do T over 8 so that it loops once in a single default GIF duration. GIF? GIF duration. And we can see this isn't a very, very dense coverage yet. So we'll need to increase our point count by a lot. It's a little better. It's still not totally full. A nice little cheat here is that instead of setting a single pixel at a time, which would take a whole lot of pixels to cover the whole shape, we can do a small circ fill to draw a little tiny circle. We'll give it a radius of 1. It's a lot closer. It's there's still a lot of gaps in there, which might be a problem at some point. I don't know. We'll see. Let's crank up our point count again. It's close. We could make a smaller shape, I guess, and then it wouldn't need quite so many. We're not hitting the limit of performance yet, but we're also not actually doing our smooth step. So maybe that's the thing we should get in there and see how expensive that actually is. So our Y is going to be the input, really it's X on this graph. So we want our Y to start below 0 and then go to 1. So let's multiply it by something a little bit bigger than 1, and then we'll subtract the difference so that it goes from negative 0.35 to positive 1. That's a pretty similar looking result so far. It just stretches downward a little farther. Now let's figure out a radius. So that's going to be regular smooth step. I did T instead of Y because I'm very used to typing out that pattern with a T. Ooh, you know what? This looks like it suggests this is an answer to our question earlier. Y has to be before X and Z because X and Z both depend on the radius, which depends on Y. Okay, well that's already kind of shapy. It looks like it's not quite wide enough at the base. So let's save a character by making that number a little bit, removing a decimal digit. That looks better. Now let's also, that's too much, add a little bit of baseline width. So that stem in the middle isn't quite so thin. Let's get in there. It's still not slowing down yet, so let's crank up our point count again. Ooh, it's still not slowing down. That's cool. You know, I feel like it's going to take a whole lot of points to really fill that in. In the meantime, let's lower our center position a bit so we can center this on the screen a little better. a really cheap thing you could potentially do is to not clear the screen. Only do it once at the beginning. And see, that gives us a shape, but I'm afraid that it's gonna give us a bad result once we're doing a different color. So let's add a color that is not just a single color. And let's see how distracting that lack of clearing is. I have a suspicion that it's gonna be bad. But let's see. Well, okay, we have a C for a potential color variable, but maybe we can just generate it right here. Now let's do a C. All right. So let's see. Let's say 5 plus I mod 3. So it'll go 5, 6, 7, 5, 6, 7, 5, 6, 7 as I increases. And that's going to give us a funky pattern because this A multiplier is like, it's like 2/3 of a turn-ish for each step. So it's not going to look quite how you'd expect. Yeah, it's not what I expected either. I mean, that's getting somewhere. The lack of clearing is a little strange, but it's not as bad as I thought it would be, actually. So that's kind of compelling. We can cheat a little more by making our radius on the circ fill a little bigger. That's okay. It's interesting how the bottom of it kind of looks like it has a bit of shading. Just because of the like leftover uncleared positions. Like if we got rid of that idea. See, now the bottom of it doesn't look quite as interesting. So I actually wonder if that's a case for keeping that. That's pretty compelling. It kind of makes it look like there's a little rim on the bottom. I actually am... I'm very down with that. I think we're going to keep that. And we're still not slowing down the renderer, so I wonder if we can push this even higher. We're getting close. Somewhere around here, it's gonna start chugging. It's hard to even tell if it's chugging now or not. Let's go a little higher. So it's kind of flickery, which maybe isn't great. What if we did I over 2 mod 3 and we get a different pattern? Doesn't look quite as interesting. 4. 7? Man, they all look pretty similar. It's all kind of a spiral. 9. Yeah, I don't know. Let's check our character count, see how we're doing. 162, not bad. Not bad. I don't know whose goblet looks like this. It's so, this crazy spiral pattern. This is some very hip bar that serves their fancy drinks in this fancy cup. That's sorta interesting. That situation on the left is pretty unfortunate. It's like really chaotic. I kind of wonder if we can cheat this a bit. Let's say that our color is dependent on Z. So we're not going to offset as much on the sides. Yeah, okay. All right. Yeah, so now we have more of the base color on the left and right and the funky pattern in the middle. It kind of it's like a Fresnel effect, right? That's pretty interesting. It's a little unfortunate that the front and back have the same, like, brightness. It makes it a little hard to read, I think. So now let's say, well, that's a bigger number. It's going to look crazy for now. We'll pick a better color palette a little later. Yeah, so let's say the range is different depending on the Z. I mean, that's gonna do something very weird. Yeah, that gives us like crazy town warping. That's not what we want. I want to map this in the same range all the time, but we want to multiply it by another Z term. Like that. Yeah, okay. So now the front has more color variation and the back has less color variation. And that's just a cheesy hack, but I don't know. Maybe it implies some more lighting information that we don't actually have. That's compelling. Let's go with a bigger number. Why is this 19 here? We don't need that. Let's just fiddle with some things real quick. That's compelling. I feel like the kind of mild spiral looks a little nicer to me than the super crazy stuff. Although, I don't know. It's kind of up in the air. Ooh, I get these really flickery bits now. That's no fun. Man, we always have these really flickery bits. What if we did like 5.9? Or like a 4.9? That looks kind of nice. It's a relatively small number of colors. And part of that's really just because the color palette is just, we have a lot of extremely different colors as we go through the default Pico 8 palette. So maybe it's time to pick our own palette so we can be a little bit more principled about how much these colors change from one number to the next. So for that, we're going to go to our other Pico 8 instance. Where is it? Over here. And we're going to load my palette maker tool. You can use this too if you go to your Pico 8 command line and do load #palette maker. It'll download it from the internet. Then you can run it and you get this little thing where you can set up a palette. So we have default Pico 8 colors and the secret alternate set of colors. We can mix and match them as we want, as long as we only have 16 or fewer selected in total. So, this is a glassy thing. So kind of grayscale makes sense, but there are more kind of reddish tones than grayish tones. There's also an okay number of green and blue. And yeah, I mean, I think the reddish ones are going to be the way to go. Kind of like a goldish looking lighting, right? Maybe it won't really look goldish, but whatever. Red is the color of fanciness, right? This is a fancy drinky cup for fancy people. So let's just grab some general reddish, orangish, yellowish colors. I feel like this yellow 10 is like always one that I pick and then get rid of because it's so harsh looking, but we're just gonna try it and see. We've got some dark purples in there too. We'll need some kind of background color. What would be a good background color? Maybe this guy. Alright, we're going to hit this magic sort button to just tell it to try to figure out, some sensible progression. And then we'll adjust it a bit because it never gets it totally right, because how could it? This is a pretty decent looking ramp. I mean, this yellow always As soon as I see it in the middle of other stuff, I'm like, God, that's not... It's too much. It's too much, man. Let's replace that 15 with a white. That looks pretty good. I feel like this is pretty much a palette that I end up using a whole lot. I'm always like, oh, we get some reds and some oranges, and I just end up back here again. These two for the ground seem pretty good. I have an extra little thought in mind for how to use two colors on the ground. But we will get to that in a second. And then, okay, so now we have a set of colors picked. We can hit this tweet button, and it gives us the shorter Tweetjam version that's using P8's key. This is one that you could do normal style to call pal to set the screen palette with the second one parameter. This does the same thing, but in fewer characters by doing a funky print statement. The question mark quotes is a shorthand for print, and then we can write weird specific codes in your print statement to do funny things. In this case, we're setting the color palette. So let's go back to here. We have that copied. We can paste it in at the top. And now we have something else. Now the colors we've picked in this demo are going outside of the range that we actually set up there. So let's see how far this goes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to 9 are the range for the glass. And then 0 and 1 are the range for the ground. 2 to 9. Okay, so we're going to do a +2 instead. And it looks like 2 to 9. This needs to be like a 7, right? So we never go above 9. We never reach 10. We get to 9.9. Yeah, there we go. All right, that's a funky looking cup. I could dig on that. Yeah, the lack of clear is actually a really big benefit to this thing because of that accident with the edges at the bottom, especially. I will take it. That I'm down. Okay, cool. Now when we clear, currently we're clearing to 0. Let's try clearing to 1. You know, I'm not sure if I like that background color. See, I need to have a lighter one and a darker one. It looks a little better to me when it's the darker one, but I don't like that lighter color. So maybe I can pick an even darker one, like that. I don't know if it's a great match. I'm not really a visual artist, so I don't have a great color intuition. I just kind of stumble around. That's my strategy. Well, let's just try that. Did that even make a change? Yes, it did. Okay. Let's try that. Okay, so now we have CLS1. That gives us our slightly brighter color. If we hit CLS0, we get the darker one. Okay. Cool. Didn't switch it back. Okay, so now, little plan for the darker part, the way to use the darker color. I would like to add a shadow for this cup. This might kill our performance, but I think that we're actually kind of okay, because even if this number was way lower, we would still have that benefit from the lack of clearing, right? So it still doesn't have any gaps in it. And also just our giant circle draws. They're they're so big, we don't really need all that many points. See, this is why I like computers. You can say 1,000 of something is not that many points. That's very strange. It's a weird situation to be in. Okay, so to draw a shadow, we need to draw the shadow first, and it's the same shape, really, right? We're going to do a loop from 0 to 1, where 0 is the shadow cycle, and 1 is the current cycle. So now let's see. Oh, man. Check this out. All right. So if the shadow is 0 and the regular glass is 1, if we want to switch from our regular color to our shadow color, we can just multiply the whole color by J, right? Because the shadow color is 0. So whatever this happens to be, we can just multiply it down to 0 if we're in shadow mode. That's compelling. This isn't going to be right yet, but let's just add whatever, J times 5. Okay, yeah, so now we see the shadow on the left, and then the main thing covering it up on the right. I can see a little bit of pass-through going on, which is unfortunate, but I think that we can work around that in a sec, so that'll be okay. Alright, so now let's see. We want to make our shadow project onto the ground. And the ground in this case is negative 0.4 on the y-axis. It's kind of unfortunate that it's not 0. That'll make us have to do a little bit of extra annoying stuff. Maybe at some point it's worth it to change this to go from 0 to 1.4 and just remap it for the sake of doing that. What if we just did that? Just scoot it back up after it's picked that smooth step radius. That'll make me have to scoot this down a little farther because we moved everything up again. Let's try 99 so we don't have to get to 3 digits. Alright. I'm going to go a little higher than that. We're getting a little close to our character limit. But I think it's going to be okay. Alright. Let's make a shadow number that's just 1 minus j. So we have this multiplier version 0 to 1, which is convenient for the color. Then we have this alternate flipped version that we can like multiply something by to say like only do this if you're in shadow mode. Oh yeah, and this is I did this backwards. This is adding a position to the real one. Instead of offsetting the shadow, it was offsetting the actual glass. Whatever. That's not how we're going to do it anyway. So, if we're in shadow mode, what's going to happen? We're going to slam our Y down to 0, but we're also going to use it to offset our X and Z. So let's start with the Y part where we just flatten it down. Negative 0.4 minus Y times S, right? So this is like the, this is like how we used to do ease toward in the Flash days. You have target number minus current number, then you multiply by your T value, and that's like, you know, move some amount of the travel remaining. Okay, that's, I don't know what just happened there. That's, oh wait, our Y is 0 now, isn't it? Oh man, yeah, Y is 0 now. That's actually way more convenient. So what if we just did Y times equals J? Yeah, same deal. Alright, that's cool. That's pretty compelling, actually. I wonder if we don't need this S. The part we really need it, I think, is for X and Z, so let's see how that looks, and then we can decide whether or not we need to keep that. Y times S. We want to scoot it when the shadow is enabled, and we don't want to scoot it when the shadow isn't enabled, right? But we're getting a little slow now. That's it's a little rough. Something else we could do though, because the shadow doesn't have multiple colors, so we can get away with like a much lower point count. So let's get a P for point count, and let's say that's, I don't know, 500 plus 999 times J. And we'll count from 0 to P, and then we'll divide by P. So now our first round for shadows has about 500 points, and our second round has about 1,500 points. Compelling. Not quite fast enough, though. I wonder if we can skip all this stuff instead of multiplying by J. As much as I like being able to do that. What does that get us? Oh, it's like the same speed. Alright, that didn't really help at all. Let's crank this down even farther. Yeah, so now you can see it takes a little while for the shadow to fill in. But that is okay, I think. The bottom doesn't look quite as nice now because the shadow draws are kind of showing through a little bit. Now also, the shadow doesn't quite look right yet. It's not quite noticeable enough. Man, it's like really not very noticeable. Like you can't see the shape, right? I wonder if I'm doing this wrong, actually. Like, is that really the shape? It doesn't look like it. I think I'm messing something up somehow. But I can't, like, what? What is going on? It, like, bends away. Like, how is that happening? I guess I can see the what do you call it? The neck, drawing a blank on my my wine glass terms. Stem. Oh, you can see the stem in the shadow now a bit. There's still that funky bit at the bottom where like the shadows are drawing through the real base, which is a shame because that base was looking pretty good. But I think that we can address that by changing our start point for the shadows as well. Let's start at like 0.2 times J. No, wait, times S. So our real glass starts at 0, and our shadow starts a little bit higher than that. Oh, but this is not normalized. We need to go much higher. Let's say like 20. So now we're skipping a bit. Let's skip a little more. Man, I don't know. If we skip too much, then we'll start seeing a gap between them, right? Like if we go really high. Oh, I guess we're not high enough yet. Oh, wait, that wasn't. Oh. Yeah, like if we go really high, that's like a gap. That's like a shadow bias bug. Man, I don't know. It's a little wonky. I really wish that that base was a little prettier. Maybe we just need better coverage. I really don't understand why that shadow is so, like, bendy looking. Like, where does that come from? There's some aspect of this I'm misunderstanding. Oh, it's because I'm doing this late. That's why. Okay, right. Oh my gosh. Okay, right. Z gets multiplied down here. Okay. Good Lord. That would explain it. Z times equals R is Y. Y times equals J. This needs to happen afterward because we're using Y right here. Okay. Now we're talking. Let's make this less extreme. Yeah, okay. Now we can see a little bit of a shadow, right? That resembles the actual shape. Hoy. Yeah, when it's farther back like that, it doesn't interfere with the base anywhere near as much, so that's cool. Like, that looks pretty much acceptable to me at this point, right? I want it to look just a little more shadowy. Yeah, that seems good. That's like getting, I don't know, you can kind of see the profile of it. That's, I think that's looking pretty good overall. I mean, the shadow looks nice. The lighting is pretty implied. Pretty, I don't know, successfully implied. There's a bit of flickering on the left side of the glass again, so maybe we can adjust this part a little more. See, there's... Right now this is Z times Z because it makes it always positive. If we just did times Z, then you would get some really wacky crap. But to keep it like that, we'd have to add 2 more Z's. That makes it a little sharper and kind of gets rid of some of the flickering at the edges. I mean, it seems like it's not slowing down, though, so maybe that's fine. Maybe that's okay. 274, we're like right up against the limit. Although I guess we could still cram a bit more in because we're not doing any like wacky line break deletion yet. Let's see. Oh man, what was even the... I usually go for 272 because then you have space for hashtag Pico8 and 2 line breaks before the code, and it still fits in 280 total. So there's a little bit of wiggle room remaining. Maybe there's space to add a little more color variation. Are we even seeing all the colors? Do we have white? Yeah, there's a white in the middle there in the highlights. Alright. Let's fiddle with something. God. Times over 2. Let's mess with this a little bit. See if we can find one that looks a little nicer, if there happens to be one. That looks okay. That's kind of compelling. Alright, 4. Alright. That's got a nice kind of smoothness to it. Looks kind of crystalline at the base. And kind of smoother at the top. Kind of like that. What was that one? 7? Yeah. I think I can dig on that. That's pretty... It's feeling pretty good. And I mean, we're right on 272. I think it's a sign. So yeah, I think I'm gonna call it there. We're gonna do a little run. We're gonna let it go for at least 8 seconds. I'm gonna burn some time talking so I can be sure that I've gone above 8 seconds. Doot. We're probably already past it. Now we're gonna remember the button for saving a clip. What is it? F9? Yes, F9. All right. We got it. First try. All right. I mean, I don't know. I think that's good enough for me. We have a little goblet. It's got some funky colors. It's got a shadow that doesn't bend weirdly anymore. Yeah. I kind of lost a little bit of the that nice rim on the very bottom. But you know what? I think I'm just going to say it's good enough. You don't have to keep every single good thing we saw. I'm just going to call it there. Thank you for watching. And I hope you, I hope you enjoyed it. And if you make any of these yourself, I want to see them. So send them to me.